Hi, this is Craig Stocks, and I'm here today for Utah Desert Remote Observatories, and I want to talk to you a little bit about using a non-destructive workflow in Photoshop, and there will be more information about this on the website at utahdesertremote.com in our blog section, and it will include two videos, the prior version or prior video to this where we go through the RGB portion, and in this video we'll go through the narrowband portion and combine the two together. If you watch the first video, you'll see that we talk about using a layer-based non-destruct workflow and the advantages of that. I'll also talk about how we captured the data and processed through Deep Sky Stacker and a program called FITS Liberator to create the red, green, and blue unstretched files and the hydrogen, oxygen, and sulfur stretched files from FITS Liberator, and eventually combine those 6 files into one final output file that uses some of everything. So in the first video we started with a base image and a hard stretch. We removed the stars, and then we did a light stretch with that same data to get star color and detail in the core. Removed the stars from that, subtracted the stars to create a star only layer, and then added the small stars and some of the detail from the core to the base. In this video, we're going to start with the narrowband information. So we'll start with hydrogen, oxygen, and sulfur. First thing we'll do is create an HOO version of that data. We'll then add sulfur and create an SHO or Hubble palette version. We can then remove the stars from that to create a starless Hubble palette. And again, I'm using Star Exterminator. We can put that underneath the RGB stars so that we have nice colorful RGB stars with a narrowband image. And then lastly, we'll kind of go back to the original RGB image, and we'll start bringing in some of the narrowband goodness, in particular the oxygen around this collar area, and then we'll also bring in some of the hydrogen in the background. We'll use a little bit of the sulfur data to add more detail to the core, and finish up with some final edits in Photoshop. And I'll mention again, I only do the final adjustments, and especially rotating and cropping, once I've saved that finished image in a PSD or a PSB format if needed, with all the layers intact. And then I do those final edits in Lightroom. If I needed to go back to make any adjustments, I can, because I haven't flattened anything. But I also have the freedom then to crop and rotate and make this whatever size I want without being constrained. So with that as an introduction, let's jump into Photoshop. So this is where we left off with the broadband image with a little bit of detail added to the core and some nice small RGB stars. Let's make some narrowband data. So I will go to File, Scripts, Load Files into Stack, and in this case I want to browse, and we want to load the narrowband data, which would be the hydrogen, sulfur, and oxygen, and I can choose those by clicking and control clicking on multiple files, or I can click on one and shift click to connect the dots, select OK, and then click Open, and that tells Photoshop to go get those files and load each one of them into a layer in a single Photoshop document. And it just takes it a few seconds to do that, and the order of the files can seem a little bit random because they won't always load in the same order, but I like to always work in the same order. So I will always put hydrogen on the bottom, and then I will always put sulfur on top with oxygen in the middle. And it's just kind of helps me keep my mind organized. These have been stretched, and they look like they might be just a little on the light side, and we're going to want to adjust these anyway. So the first thing I'm going to do is put each one of these into its own group by highlighting the layer and choosing Control-G on the keyboard, which is the shortcut to create a layer group. And now that each one is in a group, let's start with the sulfur data, and let's just add a quick levels adjustment and let's darken the blacks a little. But we don't want to make it completely black, but we can make it a little bit darker. I'll turn that group off so we can see the oxygen layer. Again, we'll add a levels adjustment and darken that background a little bit. And then we'll go to the hydrogen, add a levels adjustment, and do the same thing. And by having these in groups, each levels adjustment only affects what's in that group below it. So kind of you can think of what happens in the group stays in the group. So now that we have that done, let's turn the oxygen layer back on, and let's check our mode. So if I go to image mode, we can see these are 16-bit, but this is a grayscale. And what that means is, as a grayscale image, it doesn't have any color channels or the ability to express any color. It's only black and white because it only has the lightness or the luminosity channel. So let's convert it to RGB color so that we have all three color channels for each layer, but we don't want to merge these, so we'll click Don't Merge. And Photoshop, you may see a little bit of change as it goes from a linear to a non-linear color space. Nothing to worry about, because if we want to change something, we can always go back to these levels and change them. So now we have this in an RGB color mode. Let's go to our oxygen group, and I will double click to the area to the right of the layer or the group name. That will bring up the advanced blending modes dialog. Since this is oxygen and we want it to be just green and blue, excuse me, I will turn off the red channel, click OK, and we now have an HOO image where we're getting red from hydrogen and green and blue from oxygen, and we have an HOO version of that nebula. If we want an SHO, first thing we'll do is we'll go back to the oxygen, because instead of green and blue, we want just blue from the oxygen. I'll turn on the sulfur layer, target it, double click to bring up the advanced blending modes dialog box. And as you've probably already guessed, since this is going to be SHO, we only want red from the sulfur. We turn off green and blue, and there is a Hubble palette SHO from the same data just by flipping a few switches. The next thing I would typically do is remove the stars from each one of these layers, and to do that I'm going to want to duplicate each one of these layers so that I have the stars still intact if I ever need them for reference, but I want a layer to subtract the stars from with Star Exterminator. So I would then work through these one by one, running Star Exterminator on each one of the layers. Now that takes about 5 minutes for each layer. Rather than doing that here, I'm just going to close this and we'll open a file where that's already been done. So File, Open, and here's our narrowband data, and this will show us the SHO data just as we left it, only with the filters already run on each one of those layers. So we have an SHO starless layer, and we could have done that in the original. It would just take some time to run the filter. So now we have the opportunity for some fun. If we want to do some color balancing, we can go to the individual layers and we can change the brightness or the contribution from each one of those layers, however we want to address it. So we can edit the colors visually rather than numerically. The other thing I want to do here, and just to make it simple, we'll collapse the group. The data is still there, it's just collapsed inside the group. We have our sulfur, hydrogen, and oxygen. So if we want to take these three groups, and let's go back to our original base image, and let's select, I'll close the stars group, and let's select the layer where we added the dark details from the light stretch, because when we drag and drop, it will add on top of whatever the currently selected layer is. And if I have a group open, it might put it inside the group rather than on its own layer. So we'll grab these three groups. I've shift-clicked it to select all three. Tap V for the Move tool. Drag over to the Target tab, drag into the image, press the Shift key, release the mouse, release the Shift key. We now have an SHO version with RGB stars. I can turn those RGB stars on and off. It gives us lots of flexibility. If we wanted to go back to the HOO version, we could easily do that just by turning off the sulfur and turning on the green channel in the hydrogen. But let's look at ways we can use the best of the narrowband to augment the RGB. So first I'm going to just turn off each one of these. So there's our RGB image. We can turn stars on and off still. We can turn the big stars on if we wanted to see what that looked like. Let's start with the oxygen. So I'll turn this oxygen layer on, and it looks a little strange to start with. And let's do two things. First, let's double click on the oxygen layer, and rather than making the oxygen just blue, let's go back to the green and blue like we would in a HOO image. And secondly, rather than just replacing the green and blue layers, let's change the blending mode to lighten. And what that's going to do is bring in just the oxygen as green and blue where it's brighter than what's underneath. And if we want to tweak that, we can always go to our levels adjustment, and if we want to make the oxygen more prominent, if we want to let it seep into the background or not seep into the background, we can play with this again, play with it visually. So let's do the same thing with our hydrogen. I'll close the oxygen group. Let's turn on the hydrogen. Now the hydrogen, we never did have to do anything with its channels, but now we do because we only want the red channel from it and it's not on the bottom. So I'll double click to bring up the advanced blending options dialog, turn off green and blue, and now we have the hydrogen contribution in the red channel only. Again, if we want to tweak it, if we want the background to be brighter or darker, we can adjust the dark level, we can adjust the brightness overall, and basically just play with it to get the result that looks best to us visually. And again, we still have the stars on their own layer. Let's look at the sulfur. Now this one, when I turn on the sulfur, it will darken, and that's a nice effect around the core. It's not a nice effect everywhere else. So first let's change this to darken blending mode. Then I'm going to add a hide all layer mask. So we'll go to layer, layer mask, hide all. And now, like we did before, I can target the mask. I can grab the brush tool by tapping B for the brush tool and paint with a fairly light opacity and just paint a little bit of the darkness from the sulfur layer, especially right around the trapezium. We can turn that on and off to see the effect and decide if we like it or not. If we don't like it, we can turn it off. If we want it different, we can adjust it. At this point, we've taken an RGB image, we've added oxygen, we've added hydrogen, we've added some sulfur. We may want to do a little bit of final tuning to this, so I might add a levels adjustment on top of all of the starless layers but below the stars, and that lets me adjust the brightness and contrast of this nebula layer without affecting the stars. If I want to do some local adjustments, by specifically lightening and darkening, a good trick is I can add a blank layer and put it in soft light blending mode. And the beauty of soft light is that anything that's dark will darken what's below it, anything that's white will lighten what's below it. So with a nice big soft brush, I could start with black, for instance. Maybe I want to darken this trapezium area a little bit more. I can tap the X key to flip to white, and maybe we want to whiten or lighten some of this area around the outside. Maybe I want to lighten the area around the running man, but I want to switch to black and darken the running man itself. So it gives you the ability to just kind of paint light and dark into your image in different areas to finalize the look of it and highlight the areas that you really want to highlight. Now the beauty of all this is, if we think of this as an almost finished image, we'll actually finish it in Lightroom, but we have stars we can turn on and off. We have contributions from lightening and darkening individual areas. We have an overall lighten and darken. We may want to even add a color balance, and maybe we want to tweak the color balance a little bit to give us what we think is a more natural looking color or saturation. We can turn the contributions from sulfur on and off in the core area. We can turn the oxygen on and off in that area around the nebula. We can even turn the hydrogen on and off. If we decided we wanted to see what it looked like with the big stars, we could turn that filter off, and that's what it would have looked like with the oversized bloated stars. So I will save it at this point as a .psd file, and it actually winds up significantly smaller, about 1.2 gigabytes, which is significantly smaller than the 20 gigabytes of raw data that we started with. And all of the goodness of the data is saved here. It's all editable. I could even go back to the original red, green, and blue and make adjustments there if I wanted to. So that's how you do an overall red, green, and blue plus narrowband set of data. I will admit that by choosing Orion, first of all, hey, it's Orion, it's cool, but also it's a nice, bright, relatively easy target. So I chose one that was relatively easy so that we didn't get lost in the detail of trying to pull detail out of something that's a little bit more challenging. You can use all the same techniques with more difficult targets. You may just have to use a little bit more finesse, a little bit more of the curves and levels to try to bring out the detail. If you start with stretched data from Deep Sky Stacker or something like PixInsight, then it's all pretty straightforward. You're really just doing some basic color mapping like we were doing here, and a little bit of tweaking and maybe some star extraction with Star Exterminator. So I hope that helped you. If you found this useful, please be sure to click the like and subscribe buttons in YouTube. If you have any questions, feel free to drop them in the comments, and I'll try to answer them the best I can. So at this point, I want to say goodbye. I hope you have a great day today and an even better tonight under a clear sky. Thanks.